Yeah, yeah. I got a racket. I got a racket. I can play racquetball. Uh-huh. Yeah. No, I'm a Capricorn. I am Professor Hasskreidt, and you are not. We're going to review because Gatchuk tells me there's quiz tomorrow. So, let us review. What I am told, one of the things that people have trouble on is this, being able to interpret a graph. Here, on the y-axis, remember that as we go up the y-axis, as the graph that's illustrating our relationship goes up the y-axis, whatever is on the y-axis is increasing. Okay? Farther we get from 0, the more that it's increasing. That's a 0. You can't tell because this pen is so small. There we go. 0. In this case, we've got climbing up the rope. Back when I was a kid, back in my old country, in gym class, we'd climb up a rope, touch the top of the ceiling of the gym. Made us feel strong and tall. In America, the lawyers worry too much about that, so we don't do that here. But climbing up the rope, so the farther we get from 0 on the y-axis, the higher up you get. Likewise, the closer you get to 0, the closer to the floor you get. That makes sense. On the x-axis, we have time. As time goes on, almost always, the dependent variable is on the y-axis. The independent variable is on the x-axis. 99.9% of the time is going to be an independent variable because we can't change it. Okay, time does not change for us. We cannot climb up a rope and make 1 minute last less than 60 seconds. It ain't gonna happen. Okay, so let's follow this graph as we go. We start out at what he will ask for on the test is a brief description of what's happening. What action is being expressed by this graph. Okay, 3 or 4 sentences, not a big deal. First, the person climbs up the rope and then stays there for a nice long time. And then very quickly goes all the way up to the top of the rope, or at least as far as that person wanted to go, and then immediately slides back down. Does that make sense? Makes sense to me. Okay, you follow the story of what the line is doing. Okay, we go up the rope. You stay the same place for a little while on the rope. Okay, and then climb all the way up as far as the person wanted to go, and then quickly slid right down. All this occurring over time. Okay, if you have questions about that, you know where by this time how to contact me. EHASSKREIDT at gmail.com. Hasskreidt gmail.com. Okay. Now, let us do what the other part of the test is. A quiz, rather. He tells me there'll be a test soon. A test. You will not be able to use the notes on the test, which is bigger, more important. Okay. Next. Adding fractions. We've done this a million times. I'm going to do it one more time. Okay. Also, remember there's certain types of problems that Gatchuk likes to use. Example. Graph this. first of all, what's our problem? The problem that we're dealing with, I gotta be careful because I'm blocking my light. The problem that we're dealing with, 2,000 divided by 2,000 minus 1/7. Now, at first glance, this looks like a very difficult problem. I need to make this thicker so you can see better. ¿Está bien? Okay, 2,000 divided by 2,000 minus 1/7. At first glance, this looks like a difficult problem, but it's not because you know mathematics. Okay? Of course, I want you to graph it on this number line. How do we do this? What is 2,000 over 2,000? Any number divided by itself is 1. Any number divided by itself, 1 million over 1 million is still 1. 24,000 divided by 24,000 is still 1. Okay? Infinity divided by infinity is 1. Okay? So this is 1 minus 1/7, which is just a little bit. So where would it go on this number line? A? Would it go in section A, section B, or section C? Huh? Okay, it's 1 minus a little tiny bit. Here is 1, so it would go just about here. 1 minus 1/7. And all I'm going to ask you to do is either name the area or label it for me. I mean, not me. No, the guy got try. Okay, let's try another. Let's actually do the act of adding a fraction. All right. 1 over 6 plus 2/3. Okay, as always, we find the common denominator. When in doubt, just multiply each denominator against the other, or by the other. Okay, because that automatically makes them each other's common denominator. Okay, if you're still a little vague on your multiplication tables, that will always work. Okay, it doesn't give you your lowest denominator, but it gives you one that will work. Excuse me, mustache. Those. Okay, so let's do that right here. 18. Whoops. Let's put this farther over here. Okay, how many times does 6 go into 18? Goes in 3 times. So we're multiplying times 3 over 3, which is going to equal 6 times 3, we already know is 18. 1 times 3 is 3. 3 goes into 18 6 times. So we're multiplying times 6 over 6. 3 times 6 is already 18. And 2 times 6 is 12. What does this give us? 3 plus 12 is 15 18ths. Are you able to see that down there? Yes, you are. 15 18ths. But this is not in simplest form. And we want it in simplest form. That means the lowest possible numbers that still express the same fraction of a whole. The lowest possible numbers that still express this fraction of a whole. Simplified form. The simplified form of 15/18, and there's a certain amount of practice it takes to do this. We divide 15 by 3, which would give us 5. And of course we have to divide the bottom by the same thing, otherwise we won't get the same fraction. 18 divided by 3 is 6. This is the answer in its simplest form, 5/6. That is adding 1/6 to 2/3. Are there any questions? I can't hear you even if you have one. Email it to me, okay? Now for a little entertainment.